So we have go through sequential search for arrays. Sequential search is the most common or most universal way of search, because no matter what data type it is, what kind of array it is, you can always just go ahead and run through every element and make comparison. That being said, sequential search is very expensive. If you have a large array, large amount of data, like 1 million, 2 million rows, it will take a long time to search through these, especially because you have to go through the whole list. Given that one value can appear anywhere, either the front or the end, in general, you will run, if the array's length is n, then it will take you n divided by 2 times to find the array, statistically speaking. So if it's possible, we always try to find some way to speed up the search. Most talked about way is binary search. If you know the array is sorted, then you can use a binary search. It requires an array sorted. Textbook says it's in ascending order. Actually, you don't need to. As long as it's in order, either ascending or descending, that should be fine. It starts with the element in the middle of the array. If element is the desired value, searches over. Otherwise, the value in the middle is either greater than the desired value or less than the desired value. If it's greater than the desired value, that means we can search in the first half of array. Otherwise, search the last half of array and repeat as needed with adjusting star and endpoints of the search. So let me bring up an example. So we have an array of 1, 2, 4, 5, 7, 8, something. It's already sorted, right? It's already sorted. And let's say we want to search for 14. So we will start by pointing to start as start and end. Start will be here, 0. And end will be here. What is this end? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 0 and a 9. Then the middle of this 0 and 9 is a 4. So the mid, not precise. Remove this and type in mid equals to 4. And that's array mid equals to 7. Since 7 is less than 14, right? Because 7 is less than 14 and we know it's sorted, that means this part everything between star and mid are less than the desired value, right? Because we already know the largest of this star to mid is already less than the desired value. So there's no need to search this part at all. So we are going to put star will be equals to mid plus 1. And end is still end. So it will be 5 and 9. Which points into here. Let me use a different color. Green. Here. and here. Now 5 and 9, the mid is 7. And it happens array mid equals to 14, right? So in this case, we found the 14. What if I want to search for 16? Delete this and put 16 here. Then 14 is still less than 16, right? Which means from star to mid, again, are all less than 16. You don't need to do this comparison. In this case, we are going to put star equals to mid plus 1 again, and which will bring us to 8. And end is still 9. If we were looking for 9, then it will become different. Okay, let me change this. Let me change this to illustrate this better. So let's say we are actually looking for 9. So 9, so 14 greater than 9. Because 14 is greater than 9. Let me clean this up a bit. 14 is greater than 9, then everything after on and after mid is greater than 9. You don't need to do comparison anymore for these guys. So we don't need to consider this. Instead, star will remain the same, and end will become mid minus 1, which will become 5 plus 9, mid is 7, 7 minus 9 is 6, right? Then mid, the next round of mid equals to 5. And let me start from here. Array mid now equals to 8. And 8 is still less than, this up. 8 is less than 9. So we will do star equals to mid plus 1, which will bring us 9. 6. Mid equals to 6 now. Right. And the end equals to 6, and doesn't change. And this time, array 6 equals to 9, and we found, right? What if we are looking for, so this is how we do it. We split it into half, then split it into half again. And at this point, we just gradually, at the very beginning, it was like this range. Then we limit it to this range, and then limit it to this range, and limit this to this range. And every time we reduce the size by half, and this can bring things really fast. If the data here is not, if the desired value is not inside here, let's say I'm looking for 10. Whenever star equals to end, and AR star or end not equals to desired value, break or exit with -1. So this is a stopping condition. All right. So I hope this illustration gives you some idea on how binary search is done. Now let's look at a binary search code where you have the main method have the integer numbers, and we do a do. Inside the do, we have a star position. It will sorry. Inside the do, we have the same enter the value to search for and try to search. If result equals to -1, that's it, it's not found. Otherwise, it was found at a certain position. Then ask you, do you want to search again? Now, for this binary search, we will have star or first or last. Start, of course, starting with a 0 and the length -1. Then the position is -1 by default, and it's not found. Then we will do the familiar while found, not found, and first less than last. If first equals to last, what will happen? Because the found true is when middle equals to value, right? So middle equals to this divided by 2. Then array the middle equals to value. Then we will say found is true, position is to middle. Then we will exit. Otherwise, we'll keep on either minus last or adding first until star equals to, I think I missed the end. Okay, let me delete this. I need to add a equal sign here. Okay, if star equals to end, what will happen? Of course, we can add what I said. If star equals to end, this is one way of comparison of endpoint. Or when star equals to end, mid will become the new star. The new star, when star equals to end, mid will equals to star, because mid will become star plus n divided by 2, right? So when mid equals to star, then the new star will become mid plus 1, which will be greater than the end, right? So whenever you see star greater than end, you will know that's the end point. This is what the logic is in this Java code. So it requires first always less than last or equal to last. Whenever first is greater than last, that means we have finished all the branches and we cannot find. So we will return position because so far there's nothing changed in position. This will provide us with either the position of the desired value or a -1.